Today topic is molecular orbitals in diatomic molecules. Yes, here splitting of electrons, bonding and antibonding. What is bonding orbitals? Bonding, molecular bonding orbitals are known as lower stable, higher stable, less energy. Higher stable, less energy. Anti-bonding molecular orbital, more stable, more energy, less stable. More energy, less stable. These are the comparison between bonding and anti-bonding orbital. Main condition for formation of molecular orbitals are approximately the same energy, matching symmetry, positive overlap to form bonding orbitals. These are the main conditions formation of molecular orbital. Main important thing, right? Okay, here different type of molecular orbitals are there. Okay, different atomic orbitals. These are the atoms. These are the atoms. The atoms to combine to form the molecules. To form the molecules. Suppose this is the atom. This is the atom. 1s is atom. 2s 2p. This is the atom. Suppose this is the oxygen atom. This is one more oxygen atom. Okay, this atom is combined to form the molecular orbital. Molecular orbitals like this. This is form the molecular orbital. Yes, here also, here bonding, here antibonding. Right, like this. This is the important thing. Formation is okay. This is the formation of the bonding. See, very simple. These are the bonding. Here 1s means the s orbital existed 2 electrons, s orbital existed 2 orbitals. Here s orbital existed 2 electrons. Here s orbital existed 2 electrons. Here 2p orbitals, 1, 2, 3 orbitals. 3 orbitals existed 2 electrons. 3 into 2, 6 electrons. 3 into 2, 6 electrons. Like these are the called bonding, anti-bonding orbital. These are called molecular orbital. The atomic orbital, the red color atomic orbital to combine to form the molecular orbital. In formation of molecular orbital, we get bonding orbital and anti-bonding. How to decide? This is the lower energy, lower state, lower energy levels means it is less energy. That's why it is settled in lower stage. It is a higher stage. Higher stage means sigma star 1s. Sigma star 1s means higher state. Sigma star 1s is higher state. The electrons are settled higher state. Here 2s, 2s, these are the lower state electrons. Lower state means what happened? These electrons are settled lower energy, higher state. That is the condition. Yes, what is that? Whenever bonding orbital, thus conditions is lower energy. That's why it is more stable. The electrons are more stable in the orbital. The orbitals known as molecular orbital. The orbitals known as molecular orbitals, anti-bonding orbitals, bonding molecular orbital, bonding orbitals, and anti-bonding molecular orbital. Yes, BMO. BMO means B means bonding, MO means molecular orbital. ABMO means anti-bonding molecular orbital. Right. Here 2s. This is the bonding. This is the anti-bonding. And another one is anti-bonding. This is the bonding. This is the anti-bonding. Molecular bonding orbitals. This is the anti-bonding molecular orbital. These are the important things of that. Okay, bonding orbitals is 1s plus 1s gives rise to sigma 1s. This is the sigma 1s. 1s minus 1s gives rise to sigma star 1s. This is the sigma star 1s. 2s plus 2s sigma 2s. 2s minus 2s sigma star 2s. Right? This is the important thing. 2pz, 2p gives sigma 2pz like this. Right? This is the important thing. Right? Right. These are the molecular orbitals. These are atomic orbitals to combine to form the molecular orbital. See, 2p. 2p molecular atomic orbital combined 2p plus 2p. One 2p from this side, one 2p from this side gives us to 5 2p. S 5 2p. S 2px. S 2p minus 2p 5 star 2px. These are the s orbitals. 2px or 2py is the same energy. This is the 2py, 2px. This is the 2py. This is the 5 star 2px, 5 star 2py. Right? These are the molecular orbital. These are the blue colors. Indication is what? Molecular orbital. Molecular orbitals. Yes, bonding and anti-bonding. Okay, now splitting electrons. This is existed 2 electrons. Here existed 2 electrons. Here existed 2 electrons. Here existed 2 electrons. Here existed 6 electrons. Each one 2 electrons. Here existed 6 electrons. Each one 2 electrons. Here S combined to form the S molecular orbital. This is the theory. Molecular orbitals in diatomic molecules. We see the some examples O2, N2, and F2. We can give the example for the molecular orbital in diatomic molecule. See these. The star indication is antibody. Star indication is antibody. Star indication is antibody. Okay, configuration, electronic configuration. How to write the order? Electronic splitting order. How can you write sigma 1s less than sigma star 1s less than, and increasing order? Yes, sigma 2s less than sigma star 2s less than sigma 2pz less than 5 2px 5 2py less than 5 star 2px 5 star 2py less than 5 star 2pz 5 star 2pz. That is the last. And this is the increasing order of molecular orbitals. This is the increasing order of molecular orbitals. That's why we can write like this, increasing order. This one, this increase, energy increases, less stable, like this. Energy increases, less stable. That is the indication, right? That is the indication of the molecular orbital, right? This is the very important. You find out, yes, like this. See, one sigma 1s less than, seriously, like this. This is the important thing according to Ohm's rule. According to Ohm's rule, yes, what happened? The distribution of electrons in the molecular orbital on the basis of above rule principle. Above principle stated that orbital of lesser energy levels will be occupied by electron first. Where is the lower state orbital that electrons are occupied first? That is the important, right? This is the S order. Molecular orbitals are order. This is yes. This is less than the increasing order. This is the increasing order of the molecular orbital, like this. We should write like this. This is the important thing. That is the molecular orbital in diatomic molecules. Diatomic molecules O2, N2, F2, B2. Like these are called C2, carbon also. C2, carbon also. Okay, we can find out the electron density. Okay, the electron density also calculated by using this method, right? Bonding orbitals, right? Bonding orbitals are responsible for the increasing in electron density between the nucleus. Bonding orbitals are responsible for the increasing in electron density between nucleus. That's why it is settled down. It is more stable. This is the condition. What is why condition? Bonding orbitals are responsible for increasing in electron density. Electron density more. Yes, in between nucleus, what happened? The nucleus are more attracted. That's why this orbital is more stable, less energy. That is the important. Anti-bonding orbital reduce the electron density between the nucleus and have nodes. Why? Because the nucleus in the nucleus of the atom, what happened? Repulse and reduce the electron density. You understand? electrons పక్కకు దూసేస్తాయి. The electrons moving as a outside, out of the atom. That's why it is more repulsive. That's why what happened, it is getting in the repulsive process. What happened, it is reached the higher energy level, higher. That is sigma star, pi star. What happened, it is get reach the higher energy levels, higher energy levels. That is the antibody. This inner cell overlap is insignificant and they can be ignored. Okay, that is the point. Okay, first bonding is the attraction of nucleus and repulsion of nucleus. Attraction of nucleus means bonding orbitals. Repulsion of nucleus is antibody. That's very important. Very important. Yes, very important. These are the based on these rules. They occupy the electrons. Occupy the electrons in the orbitals. Right. These are the very important of. Right. Yes. So from this splitting, we can calculate bond orders. How to calculate bond order? Yes. How many electrons are settled in bonding orbital? This is bonding. This is bonding. This is bonding. These are the bonding. Yes. Without star also, only bonding. Star is indication anti-bonding orbital. We can calculate it. How to calculate? Like this, right? Bond order means is the number of covalent bonds formed in the molecule. It is given by one of the difference between number of electrons in bonding orbitals and those are anti-bonding. The bond order is nothing but number of electrons in bonding orbital minus number of electrons in anti-bonding orbitals by 2. That is half means by 2. That is called a bond order. Bond order is equal to 2 means 2 bonds between atoms. Bond order is 3. 3 bonds between atoms. That is important. And bond order is 1. That is means 1 bond between molecules. That's very simple. Based on bond order, we should calculate the bonds between the atoms. Yes, bonds between the atoms. One single bond. This is the double bond. This is the triple bond. This is single bond. Like this. Like this bond. Single bond is there like this. Right? Very simple. Number of bonding electrons. Number of anti-bonding electrons. Number of bonding electrons minus number of anti-bonding electrons by 2. If number of bonding greater than number of anti-bonding, what happens? The molecule is more stable. The electrons ఎక్కువగా ఉన్నాయనుకోండి bonding electrons in bonding orbitals getting more electrons, this is more stable. This is the more stable. That is the important thing of the molecular orbital. This is very important of the bonding orbitals, right? Okay, give some examples also we discuss. What is the yes, examples: oxygen atom move plus move, 2 atoms to combine molecules O2. Yes, the atomic number is 8. The electronic configuration of O atom 1s2 2s2 2p4. Right. Now electrons are splitting here. Yes, one oxygen atom O this side, one oxygen atom O this side. Yes, now splitting. How many electrons in oxygen atom? 8. 8 plus 8, 16 electrons in the molecular orbital. Now find out the how many electrons are bonding, how many electrons are anti-bonding. Right? We should calculate by using molecular orbital theory. Molecular orbital theory. This is the molecular orbital theory. Okay, 1s is common. This is the non-bonding. Right? Now form. Here is how many electrons? 8 electrons. Here 8 electrons. Now participate 2s, 2s. 2s is 2 electrons. 2s is 2 electrons. Now combined like this. 2s is yes 1 electron. Yes sigma 2s, sigma star 2s. This is the anti-bonding. This is the bonding. 1 electron from this side. 1 electron from. First filling the bonding orbital. That is the important. I'll show the curve. This is the bonding orbital. Next remaining electrons fill the antibond. Now here antibond. Right. First filling here 4 electrons. 2 electrons are settled here. Remaining 2 electrons are settled here. Okay. 2 electrons is bonding. Another 2 electrons is antibond. Coming to the 2p. In 2p, 1 electron filled here. Another electron is here. One more electron here. One more electron here. And one more electron here. One more electron here. Paid. After fade, yes, we will go for next orbital. This is single electron, this is single. This is the important. Like this, fill it. Yes, right. Fill it. 2pz, 5, single, single. Yes. And last is 5 star 2px, 5 star 2pz, 2px. 5 star 2pz is 0. No electrons in the molecules. No electron. Number of electrons in O2 molecules equal to 16, right? Okay, coming to the point, very interesting. How many KK indication is this is the non-bonding. That is the KK quantum. That is the KK. And sigma 1s2. This is the sigma 1s2. Sigma star 2s2. This is the sigma star 2s2. And sigma 2pz2. This is this one. And is it 5 2px2. This is the 5 2px2. Next 2py. 5 2py2. This is the 2py2. And last 5 star 2px1. And last one 5 star 2py1. These are the splitting, no electrons. Completely, this is the 8, 8. Total electrons is 2 plus 2, 4. 4 plus 2, 6. 6 plus 4, 10. 10 plus, how many electrons are there? How many electrons? Okay, total 12. Like here is 4 electrons. 12 plus 4. 16 electrons are there. Total electrons are 16 electrons in the S oxygen molecule. Like this. This is the important. Right. Next molecule. Okay, what is the bond order? Bond order. Number of electrons in bond 2, 2, 2, 2. Total is how many electrons? 2 plus 2. Star 2 plus 2, 4. 4 plus 4, 8. Bond order equal to 8 minus 2 plus 1 plus 1. 8 minus how many electrons? How many electrons? 8 minus 4 by 2. Yes, cancel చేస్తే అవుతుంది. Yes, 8 minus 4 is 4 by 2. That is the bond order is 2. Are you following? Bond order is 2. How many bond electrons? 1, 2, 3, 4. Count bond electron. This is the 2 electrons. This is 2 electrons. This is 2 electrons. This is 2 electrons. Bonding electrons. Yes, bonding electrons 2 plus 2, 4. 4 plus 4, 8. Bond order equal to number of electrons and 8 electrons minus 4. This is the 2. This is 1, 1. 4. 8 minus 4 by 2. That is 4 by 2 equal to 2. Very simple. 4 by 2 equal to how many electrons? 4 by 2 is equal to 2. The bond order is 2. That is the bond order is 2. And O double bond O. That is the indication. O double bond. O double bond O. That is the important. Right? Unpaid electrons. 2 unpaid electrons are there. Not paid electrons. As 3 unpaid electrons, O2 molecule is paramagnetic. How can you see? There is unpaid electrons. These are the outermost electrons. Unpaid electrons, that's why it is a paramagnetic. That is the bond order is 8 minus 4 by 2 equal to 2. This bond order is 2. O double bond O. That is the bond order. This is therefore double bond is formed. This is the important. Next molecule. See the next molecule is F2. F2, F plus F, F2 molecule. The electronic atomic number is 9. The electronic configuration is 1s2, 2s2, 255. Right. Here 10 electrons. 1, 1. How many are there? Atomic number is 9. 9. That is filled. Filled. Here 2 plus 2 plus how many electrons? 4 plus 5, 9. Yes, 4 plus 5, 9. Right. Molecular orbital. This is the non-bonding. 2s, 2s. This is the bonding. Sigma 2, 2s. Sigma star 2s. Sigma star 2s. Right. Okay. Sigma 2pz. Sigma star 2pz. 5 2px, 5 2py. 5 star 2px, 5 star 2py. Like this. Filling up all electrons. From this side, this side, this side, this side, this side. Sharing electrons from this side. ఇక్కడ నుంచి పైనుంచి రావట్లేదు, ఈ పక్క నుంచి వస్తున్నాయి, అది గుర్తుపెట్టుకోండి. Right now electrons are filled. No unpaid. All electron or orbitals are paid. They are paid. Paid means what? This is the electronic configuration. Electronically, it is also electrons are paid. F2 molecule is diatomic, diamagnetic, dimagnetic. Bond order count. How many electrons? 2 plus 2 plus 2 plus 2. 8 minus 6. Antibonding. That is the 1. Bond order is 1. F. That is the bond order is 1. That is the important thing. Yes. Number of electrons are calculated by using this one. Right. Comparison of oxygen and fluorine. Comparison of oxygen.